Welcome everyone and good morning. We'll be waiting just a few more minutes just to get started as a courtesy to those people still trying to connect. Good morning and welcome everyone. Thanks for joining us in today's session and being part of our community. We have some great content planned for today's session, but before we start, I'd just like to go over some housekeeping items. Excuse me. Feel free to ask questions at any time by typing in the I am window. Be aware that anything you post will be publicly visible. If you prefer, you can post your question anonymously by checking the box right below where you enter your question. We've had a large number of people register for this webinar and across the series. We're really thrilled to see this level of interest. Please bear in mind that it might be possible or might not be possible to answer all questions during today's session. We do have people standing by to answer your questions and we'll do our best to answer as many as we can during the call. If you visit aka.ms/AIP Q&A, you'll see a place dedicated to webinar questions. We'll review the question transcript after this webinar and post further answers to that location. If you're listening to the recording after today's session, this is also the place to post your questions after the event. We are recording today's webinar and this will be shared publicly. We will be posting the recordings on our community at aka.ms/AIP recordings. Talking of community, if you're not already signed up, do come and join us at aka.ms/security community. This is the best way to ensure you don't miss out on any future webinars. It's also where we post major announcements and a place where you can interact directly with our engineering teams that create our security products. You'll also be able to influence our product designs, get early access to changes by doing things like participating in private previews, requesting features, reviewing our roadmap, and attending in-person events and webinars like today. As I mentioned, we have some great content planned. Today's session is part 6 of our 6-part series on Azure Information Protection, or AIP for short. Throughout the series, we've been walking through all the major features of AIP and showing you how to deliver and configure each part. So I'd like to introduce you to the team on the call today. Martin Sieber will be presenting and is one of our resident AIP experts on the call. He's a program manager in our AIP team and part of our Get to Production group. As part of his role, Martin helps customers deploy AIP on a daily basis, so he's well suited to help with today's topics. On the call, we also have Avi, Nia, Chen, and myself, Adam, to help answer questions. So with the housekeeping covered, I'll pass on to Martin to get started.
Thanks, Adam. Good morning, everyone. First, let me say that I'm not a developer, but I'm still interested in how to build software leveraging Microsoft Information Protection. So here's our agenda. First, we provide a quick recap on MIP. We explain the purpose of the MIP SDK and list some partners that already integrated with this SDK. Then we provide a high-level overview on the MIP SDK, show some of the main use cases of the individual components. Last but not least, we walk through the C++-based samples. Before we start, yesterday, version 1.2 of the MIP SDK was released, but the whole preparation and the samples are still based on the version 1.1. Just saying this for you not to get confused. But it's definitely worthwhile checking the new SDK has some nice new features. Coming to the overview, this gives a comprehensive view of the different information protection technologies that customers might evaluate as part of their overall strategy. Many of these capabilities already work closely together, and we will continue to build in the right connections so that sensitive information is protected throughout its journey. For your information, we will take care today about the SDK for partner ecosystem and ISVs. Microsoft Information Protection helps you to discover, classify, protect, and monitor data. This works across devices, applications, cloud services, and on-premises alike. MIP aligns content detection and classification on Office 365 Information Protection, Windows Information Protection, and Azure Information Protection. The whole experience is managed on the Microsoft 365 Security and Compliance Center. After this brief overview, let's jump into the SDK. The MIP SDK covers several platforms. See the right-hand side. All these platforms are GA by now. It tries to provide a consistent experience, broaden the reach, extend usage to other apps and services. And finally, it's compatible with Microsoft IRM and ADRMS. Here's some MIP integration partners. Adobe, for instance, has released an add-in for their Acrobat Reader, which allows opening protected PDFs. Palo Alto Networks has integrated MIP capabilities in their edge firewalls. That's just two examples from our partner landscape. Here, you see an overview on the APIs involved. We'll have a closer look at the File API, Policy API, Protection API, and going through samples to see how these APIs are being used. The MIP SDK is structured among the following classes. Profile. This is the root class for all SDK operations. Engine. That's the interface for operations in context of an identity. And handler. Handler, for instance, a file handler for files, a protection handler to encrypt or decrypt bytes. Let's look at some concepts that are new in the MIP SDK. The SDK extensively uses the observer pattern for getting the asynchronous callbacks. By using delegates, developers can plug in custom code for tasks such as handling authentication and getting user consent. We will have a closer look on the observer pattern and the delegate model when discussing the SDK samples. The Protection API shields the application developer from writing his own code for handling the key exchange, as one example. We will also look at the C++ sampler leveraging the Protection API. The Policy API covers mainly the policies associated with labels. One use case for this API would be a DLP platform needing to read labels. A sample for this API will also be discussed later. The File API allows handling protection with various file types. The first two C++ samples, which we will look in, are based on this API. In this section, we will walk through prerequisites and steps needed for running the C++ Quick Start and the C++ SDK samples on a Windows developer client. We'll get to know better the C++ Quick Start and the SDK samples for the File API, Policy API, and Protection API. As you can see, this session is focusing on the C++ MIP SDK samples. For samples based on C#, I encourage you to also attend the webinar held by my colleague Rafael Dominguez, who is based in New York. His session is on Thursday at 3 p.m. Eastern Daylight Time. That's 9 p.m. in the Paris time zone. Let's jump into the service prerequisites. The first prerequisite is a tenant. Now, this can be a trial or a paid tenant. It works either way. One or more of the licenses listed on the left-hand side need to be assigned to test users in this tenant. In the sample you see on the screenshot, the user MIP test user 1 has been assigned both an EMS E5 and an Office 365 E5 license. For running the SDK samples, one of these licenses would already have been sufficient. But of course, it does not hurt for this user to have both licenses assigned. Another prerequisite are the sensitivity labels. You need sensitivity labels in the Office 365 Security and Compliance Center. Now, if you started with labels in the Azure portal, we suggest you migrate these labels to the Office 365 Security and Compliance Center. On the resources slide at the end of this presentation, you will find the link to the instructions. Here you can see a bunch of labels, main labels, personal, public, general, confidential XY, which is a rather odd name for your production tenant, never mind. And we have some sublabels here as well. Another prerequisite might be the IPIA. The Information Protection Integration Agreement, in short, IPIA, is a legal administrative component which will not be discussed in greater detail during this call. We just want to remind you it's needed for ISVs shipping an application or for customers going live with their own custom applications. For more details about IPIA, suggest you consult the link in the slide. Now, let's switch to the prerequisites for the developer client. Make sure Windows 10 is updated to version 1709 or later. You also want to enable the developer mode. This comes along with file extensions being shown. Of course, you're also allowed to enable the developer mode if you're not a developer, but when you run these samples, it's probably better if you enable the developer mode. Once the prerequisites are fulfilled, you download and install Visual Studio 2017. Here, you make sure the Windows 10 SDK and the C++ Universal Windows Platform tools are checked during the installation. This assumes you want to run the samples in C++ as well, which we are going to cover in this session. Then you use an elevated PowerShell prompt in order to install the adal.ps PowerShell module. The warnings shown on the screenshot are to be expected. You need to confirm with yes or Y each time to get this module installed. In Visual Studio, the SDK can actually be installed in several ways. Here, we'd like to show you how this is done with the NuGet Package Manager console. You open the NuGet Package Manager console on the Tools menu. Then you run the install package commands specific to the package needed for the tool. You'll see these commands highlighted in the lower screenshot. For downloading the SDK samples, you may use the Git client tools. The screenshots show how to install this tool. So you continue through the wizard for installing this tool. Select install and wait. And once completed, you may start git bash. In git bash, you can download the samples with a git clone command, as highlighted again on the screenshot. You may repeat this step for each SDK sample you want to download. Now, with the whole environment prepared, let's get our hands on some code. The C++ Quick Start can be built by following the step-by-step instructions. You'll find the link to these instructions on, again, the last slide of this presentation. We are not going through these individual steps. Instead, we have a look at the resulting code. Here you see the main function, and you see here the profile observer, authentication delegate, and consent delegate objects, or rather their implementation specific to this project being instantiated here. In line 28 and 39, we added a simple tracing to better understand the program flow. Once we run the program, we will see these messages and can see in which areas of the code are being passed. The method acquire OAuth2 token is being called by the MIP SDK. So basically, you define this function and the SDK calls out on this function. In the quick start sample, we rely on the user running a PowerShell script for getting authentication done. As you can see here, the user is asked to enter an access code, the access token. Now, he does not know that by heart. So we need to run a script for that. This PowerShell script here, as highlighted here, calls the ADL library. The call prompts the user to authenticate against Azure AD. This way, the token is acquired and being copied into the clipboard. That's the last line of the script. The user will then have to paste it in the command line as requested here in this upper screenshot. As mentioned previously, I adapted the sample, adding some simple tracing to better understand the program flow. That's the kind of trace messages resulting from these edits. The user has now pasted the token from the clipboard. A same sample token is highlighted on the screenshot. Upon receiving a valid token, the sample application lists sensitivity labels. Again, some trace messages, and then you can see here the sensitivity labels. This section illustrates the asynchronous creation of the file handler. In the first highlighted lines, we see the so-called promise and future for the file handler. In the second highlighted line, execution of this thread waits until the asynchronous operation in a separate thread has completed. Similar to the last slide, here we show the promise and future involved in labeling the file asynchronously. Again, the thread waits for completion of the operation in the separate thread. In this example, in this text mode example, running the operation asynchronously may seem a pointless exercise, since there is no action between starting the asynchronous operation and waiting for the result. And we're actually waiting until it completes, no matter how long that takes. But in real-life applications, we may perform other actions. In the meantime, we may update the screen, etc. And we may, for instance, wait for 3 seconds only, assuming if it didn't succeed within 3 seconds, just as an example, there is some issue anyway, and we will just forget about that, and we'll issue an error, etc. Here's some other edits, apart from adding the trace lines explained before. Here, by adding 4 lines of code, we can set additional properties. Here, we assign a department and a vendor ID. Like other information related to the MIP labels, this information is visible in Word as custom properties. So basically, this allows you to programmatically set custom additional properties, which can then be evaluated by other programs or by other applications written with the MIP SDK. In our code, you see the highlighted application ID. That's the GUID here. In the AIP activity logs, assuming you have enabled AIP activity logs, each access of the MIP SDK client is listed. So you can see here, I clearly had to run several attempts to get the things done the right way. And here, in the activity details, you will see the application ID. So basically, this allows you to figure out who, where, on which device did actually run your script, your tool. Because that's your application ID, that's what you assign during compile time to your tool. We're now having a look at the File API C++ sample. Unlike the quick start discussed before, the samples illustrating File API, Policy API, and Protection API do not require the user to run any PowerShell scripts. Instead, they get the access token with a Python script which is called by the sample applications. For the sake of simplicity, usernames and passwords are hard-coded in this sample. Needless to say, this is not recommended for production code. This is just to make the setup of these samples simpler. To get these scripts running, you will have to install a Python 2.7. you can download here. Then you have to add the program directory, which is C Python 2.7, to the Windows path. So you add that to the environment variable, system variable path, and you include C Python 2.7. Like in the quick start example, the method acquire OAuth 2 token of the delegate implementation class is called by the MIP SDK for authentication. Now, again, this method is called, but instead of telling the user to run a PowerShell, it in turn calls the function acquire token, custom function, thereby passing username and password. The function acquire token, which has been called in the last slide, invokes in turn a Python script, again passing username and password to this Python script. If successful, if username and password and everything was correct, the Python script returns a valid token to the function acquire token. This valid token is then being returned and used for authentication. When we run the file API sample, it lists the labels, lets the user choose a label, and asks for a path to the file name, and labels protects that file. Please observe, we again have some trace messages here to allow us better to see the program flow. You will not get these trace messages when you just download the samples. I had to add them myself to get a better overview on where and how the program flow works in these samples. Now let's move to the policy API C++ sample. The custom class action of the policy API sample contains various MIP objects. The constructor accepts a MIP SDK application info as an argument. The method add new profile of the action class loads the profile asynchronously. Here you can see again promise and future for these asynchronous calls. So we again wait until the call completes by calling the get on the future. Similarly, the method add new policy engine of the action class loads the policy engine asynchronously. We again wait to the call to complete here. The method list labels of the action class prints all labels on the output window. The labels are retrieved from the policy engine with the method list sensitivity labels. The method compute action dumps the details about label, about one particular label, specifically the action types metadata and protect by template, as highlighted here on the screenshot. But keep in mind, there are other action types besides metadata and protect by template. This means your program might have to evaluate additional action types depending what you have in mind with your application. Here's the output of the sample when we run it. Take note of this protection template associated to this label. That's the label we selected. And here we have the protection template. It's shown by template ID. This shows the label has predefined user rights. To be clear, not every label has protection template associated with it. When running this sample on a label that does not have predefined user rights defined, you will not see the line starting with template ID. You may expect the label, however, the metadata information of the label, which is in the lower part here. Now we have a closer look at the last C++ sample. This is covering the protection API. In this sample, the action class contains a member function for listing templates. Unlike the previous sample, this function dumps the templates and not the labels to the output window. If you check the source code in the upper left-hand side, you'll see the custom action class containing a member for getting a publishing license. Here's how you get a publishing license. The member function protect string, shown now, leverages the serialized license to protect, meaning to encrypt string. This is shown in the lower right-hand side of the slide. When running the protection API sample, you see it lists templates and protects unprotected string. So here in the upper part, it lists the templates, the protection templates. And after selecting one particular protection template, that's a template ID with starting with 6.1, you're asked to enter some text. My sample would have been, this is a secret text. And then it applies this protection where you can see the text is encrypted, and afterwards it decrypts the same text again. Here you find some references to the MIP SDK. Allow me to remind you to the webinar focused more on C# held by my colleague Rafael Dominguez. I hope I see you also on Thursday at 3 p.m. Eastern Daylight Time. With that, I've concluded the presentation. I may hand back to Adam.
Thanks for that, Martin. That was a great session. There's not been a lot of activity on the question side of things, so I think from that point of view, we've got everyone in stunned silence. Will probably be a good time to wrap up the session. So I just want to say thank you, Martin, for the presentation today. Thank you, everybody, for attending. We do have the slide up or coming. Do you have the bookend slide there at the end, Martin? Basically, we have the rest of the series on aka.ms/AIP webinar. You can see the 5 previous sessions there available for streaming, and the presentations should be up shortly if they're not already. We have recordings at AIP recordings, so aka.ms/AIP recordings. We've also got the Q&A overflow for the series available at aka.ms/AIP Q&A. And of course, our community at aka.ms/security community. I will post all of these to the chat channel window momentarily if you haven't got them already. So if you haven't seen all of the sessions in the series, it is worth going to look at the recordings. We've had some excellent content over the 6 episodes. You can go back, you can stream any of the previous sessions. If you have questions that come up from those sessions, you can also post them at the Q&A link, which will be monitored by our community guys, and we will answer there appropriately. Please, if you haven't already, come and join our community. As we pointed out at the beginning, it's the best place to keep abreast of everything we're up to and get involved at aka.ms/security community. Thank you for joining us today. Thank you for joining us over the series of the webinars. We hope to see you again when we do more of these. We look forward to your input. Thank you very much.